Hi, I'm Paul Battaglia, and this is section 4.7. As we end up this chapter, it's important to note that students already have a wide array of skills. They know basic integration rules, they know more complex strategy, and as recently as 4.6, they've expanded the inventory of functions that they know how to integrate. So now it's time to give them one more group, and that would be inverse trig functions. So the essential question we would like students to be able to answer at the end of section 4.7 is, how do I integrate certain inverse trigonometric functions? So strategically, how can we approach this in class? Well, the great thing about 4.7, like a lot of some of the other sections we've seen, is that mathematical practice number 3 is still being achieved here. Not only are students learning how to select the appropriate strategy, but now they're looking at the algebraic and computational processes necessary to integrate. So here's where I would start. I would have a nice thorough look at theorem 4.20. And the reason is because I want students to focus on arcsine and specifically arctangent, those two. What I want them to do is I want them to be able to compare these with things they may have seen in the past. For instance, on the board I might throw up something like, look at the integral of x over x squared plus 4 dx. Meanwhile, take another look at an integral that is dx over x squared plus 4. Now they look very, very similar, but they are different, and our approach to them has to be different. Can anybody tell me why? Now hopefully you'll see students who are conjuring up images of things that we talked about earlier in the chapter. X over x squared plus 4 does not yield an inverse trigonometric function. That can be handled using u substitution, like we saw in 4.5. However, dx over x squared plus 4 will yield the inverse tangent function. So for that reason, it's important that students start to notice the difference. And as I've been saying to them throughout the chapter, you can't just focus on what we're doing right now. You need to start creating a catalog in your mind of strategies and an inventory of functions so that you can put all the pieces together. Speaking of that, how about this? Now that this is pretty much the last function that an AB calculus student would need to know how to integrate, how about we ask them to create a summary, if you will, of all the functions that they know how to integrate, all of the rules. See how far along they can get. And to be honest with you, I might even ask them this as a warm-up in class or a good way to end this class, because I want to know, how many can you remember just off the top of your head without referring back to your notes or the book? Really nice activity to get students feeling good about what they know. Now, let's take a look a little bit at some common mistakes that students may make. In example 1b, they'll notice that it looks pretty simple, pretty basic, but there's a need for u substitution. So I mentioned earlier a particular integral, and this one's no different. If we let u equal 3x, then we are off by a 3. So we need to compensate by that 1/3. So same technique we used in section 4.5. Now likewise, students can then go to examples 4 and 5, and they might make some mistakes there, but there's good news here. 4 and 5 are a little bit out of bounds, let's say, for things that they might encounter, certainly on assessments that I give them, and maybe even on the AP exam itself. Okay, finally, let's look at examples 6 and 7. Specifically, let's look at 6c and 7c. See, in both of these problems, what we're doing here is we're asking students if they recognize how to go about integrating these problems. And the short answer is they don't. See, in A and B of both of those examples, these are integrals that students should recognize. So why are we highlighting examples 6c and 7c? Because I want students to see that although they have a vast knowledge now of how to integrate certain things, there still are some things that they don't know how to integrate. And if you're an AB student, will not learn how to integrate. BC students, a little bit of a different story. So to finish up, just remember this. Emphasize to your students that arcsine and arctangent are the two inverse trig functions that we really want to focus on in this section. I hope you found these tips helpful. I'm sure you'll have much success in section 4.7.